Good morning, girls. Today topic about prime numbers. A prime number is an integer that can only be divided without a remainder by positive and negative values of itself and 1. You know what is a prime number, right? 2, 3, 5, 7, 11. These are the prime numbers. How can we say that a prime number 2 is a prime number, 3 is a prime number? So these are a prime number is nothing but it is an integer. Okay, so it is a divided, it can be divided by itself or 1. Suppose you consider 2 divided by 2 only. Okay, and you can divide 2 divided by 1. You consider 3 divided by 3 divided by 1. You cannot, if you divide 3 by 2. Okay, 3 divided by 2. So then you got the remainder, right? Remainder 1. So here the meaning of prime number is the prime number is a number, that is it is an integer that can only be divided without remainder. That means if you divide, that remainder must be 0. Suppose you consider 2 divided by 2, that means the remainder is 0. Okay, so you divide 2 divided by 1, the remainder is 0. Okay, that means without the remainder means the remainder is 0. Okay, so not other than the 0. Okay, so here a prime number is an integer that can only be divided without remainder. Okay, by positive and negative values. Either it may be a positive value or a negative value. Okay, but you should not have any remainder. Okay, so here consider 2. 2 is a prime number. 2 divided by 2, it gives a remainder 0. Okay, that means it is not having any remainder value. Okay, so next you consider 2 divided by 1, it gives a remainder 2. It gives a remainder 0. Okay, so next consider 3 divided by 3 divided by 1. Okay, for those itself and 1. Itself in this is the name, the number. Okay, so you consider 3 divided by 3 itself. Okay, so 3 divided by 1, it gives the remainder 0. Okay, suppose you consider 3 divided by 2, it gives the remainder 1. It is not the prime number. Okay, so is it clear? Hope you understand. Next one is prime numbers play a critical role in both number theory and in cryptography. So you know what is a prime number. Okay, so prime number is nothing but integer. It doesn't having any remainder. Okay, the number can be divided by itself is nothing, itself and 1. Number can be divided by itself and 1 is nothing but the prime number. So here prime numbers, here we are discussing these prime numbers in the subject of cryptography, right? So this plays a main role in the number theory and cryptography. Okay, so in cryptography and number theory, the prime numbers played a major role. Okay, so next one is integer. So here they have simply given the definition that a prime number is divided by itself and 1. Okay, so here an integer p greater than 1 is a prime number. Suppose you say integer p, consider here p is an integer, is a prime number. Okay, so the integer must be greater than 1. Okay, you assume that an integer p greater than 1 is a prime number. That means p is a prime number if and only if its only digits are plus 1 and plus or minus p, plus or minus 1 and plus or minus p. So what it means is meaning same as the first one. Okay, so a prime number is an integer. So here p is an integer. Consider the letter p is an integer. Okay, so integer, and also say that it is a prime number. If we are saying that p is a prime number, okay, that p having the divisors 1 and p, that means p divided by itself and 1. Okay, either it is a negative value or it is a positive value, plus or minus 1 and plus or minus p. Okay, an integer p greater than 1 is a prime number if and only if its only divisors are 1 and p. Okay, so next here I have written the 50 prime numbers up to 50. The prime numbers up to 50 are here 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. Okay, these are the prime numbers up to the number 50. Okay, so here, so consider 17. Okay, 17 is a prime number. Why? So it is not divisible by other number. Okay, so if it is this if you divide with the other number, okay, if you take any divisors, okay, so that should not give the remainder, okay, 0. Okay, that means 17, you are dividing the 17 by 2. Okay, 17 by 2, so here it gives, okay, so 1 as a remainder. Okay, so it giving the reminders. Okay, but here prime number is nothing but it is integer, so it is not having the divider, sorry, it is not having the remainder. Okay, and it can be divisible by itself. Okay, right, 1. Okay, so that is about the prime numbers. Okay, so next, so here is some uses of a prime number were used in number theory. Okay, fundamental theorem of arithmetic. For fundamental theorem of arithmetic, they are using the prime numbers. Okay, so here we are going to discuss about the use in the use of prime numbers in the number theory. Okay, so fundamental theorem of arithmetic. So suppose any integer, consider any integer a greater than 1 can be factored in a unique way. As suppose you consider this equation a equal to p1, p2, p3, p1 power a1, p2 power a2, p3 power a3 and so on, pt power at. Okay, suppose a is an integer, you consider one integer. Okay, so that integer must be a factors of prime number. So here p1, p2, p3 and so on, pt are the prime numbers. Okay, so and there the powers a1, a2, a3 up to a3, sorry, at are the integer, positive integers. Okay, so positive integers. So suppose you can consider a1 value as 1, a2 value as 2, a3 value 3, like that you can take any positive integer number. Okay, positive integer. Okay, the prime numbers p1, p2, p3 must be prime numbers. Okay, so by multiplying all these prime numbers, that means p1 power you consider one positive integer into another prime number power some positive integer, that must be equal to given number. Okay, so next, see here p1, p2, pt are prime numbers, and also observe here p1 must be less than p2, p2 less than p3, like that, less than pt minus 1 less than pt. Okay, these are the prime numbers. A is nothing but the positive integer. Okay, so next one, take an example here, 91. 91. So here consider a is 91. Okay, so how 91 we are getting? By multiplying the prime numbers. Okay, so 7 into 13, 7 is a prime number, 13 is a prime number, 7 power 1, 13 power 1. Okay, so next consider one more example, 18. 18 equal to 2 power 1 into 3 power 2. So here 2 power 1 into 3 power 2, 2, 3 are the prime numbers. Here how we are getting 18? 2 into 9, 2 nines are 18. Okay, so how we can write this one in the form of prime factorization? So 2 power 1 into 3 power 2. Okay, we got 18. Consider the third one, 36. 2 power 2 into 3 power 2. That means 4 into 9. 4 nines are 36, right? So we are getting a, we are getting integer by multiplying prime numbers. Okay, for the prime numbers, if there is a need, you can take the power. Okay, so that is the fundamental theorem of arithmetic. We can also write this equation in another way. Okay, that is, okay, so here we have considered the product of prime numbers, right? Like that, here also we are considering the product of prime numbers. Okay, so if P is the set of all prime numbers, okay, then any positive integer A can be written as. So here we have taken P1 into P2 into P3 like that. Here in another way we can write the same product. You know product how we are write, we represent the product in the form of pi. Okay, so observe here, A equal to pi. Okay, so here P belongs to P. So the first P is the prime number that indicates the prime numbers. Okay, so okay, if P is the set of all prime numbers, okay, then any positive integer A can be written as. See here, this is the capital P and this one is also capital P. This is the small p. So this capital P represents the set of all prime numbers, set of all the prime numbers. Okay, this P represents whatever. So suppose to get A, what are the prime numbers we need that represents this P. Okay, so product of small p, this one is a small p. Okay, product of P power A P. So here observe that what the difference between both these equations is. Okay, the difference is, so here A1, A2, A3 and A80. So these are the A1 or the positive integer, but observe here P power AP. So whatever the P we are taking here, we must give that P here. Okay, we must use that value here. Okay, so where each AP greater than or equal to 0. Let's see an example. See here, consider A is 12 equal to pi. So small p belongs to capital P. Here what is small p? What are the prime numbers we need to get the value A. Okay, here A value is 12 pi. Okay, P power AP. So here the small p is 2 3. There is a chance of 2 3. Okay, we have the prime numbers 2 3. Okay, so 2 into 3 6. No, so 2 into 2 power 2 into 3. 2 power 2 in the sense 4 into 3 12. Okay, so here pi, there is a chance we are taking 2 3. Okay, that belongs to set of all the prime numbers. In this is 2 3 5 7, all these are the prime numbers. Okay, these 2 3 belongs to this set only, right? All the prime numbers only. Okay, so now we elaborate this one. So here pi of P power AP 2 3 belongs to this P. This is the small p, this one also small p. Okay, so here P possibilities are 2 3. Okay, so here P possibilities also 2 3. So here 12 equal to, how can we write that? So in place of P I am taking 2 3. Okay, so first I am taking 2 power A. Here what are the value? Here we are taking that value has to take here. Okay, 2 power A 2 into, okay, next 3 power A 3. Okay, so next what is the A here? So we can take A value as A. This A2 A3 also you must take the prime numbers only. Okay, sorry, no need of taking the prime numbers here. So it just represent why we are taking A2 A3. Why should not take A1 A2 like that? Because here why we are taking A2, the prime number is 2. Here we are considering the prime number is 2, so that here it is a2. So here we are considering the prime number is 3, so that we are considering the number is 3. Prime number is 3, a3. Okay, you should not take a1, a2 like that. Oh, okay, so it is based on the prime number you are taking. So 2 power a2 into 3 power a3. So how we are getting this 12? If a2 is 2 and a3 is 1, then we can get the value 12. Okay, so next one is, this is fundamental theorem of arithmetic. Okay, so next one is multiplication of two numbers is equivalent to adding the corresponding exponents. Multiplication of two numbers. Okay, so here these are the uses, okay, where we are using this a prime number. Okay, here, so multiplication of two numbers is equivalent to adding the corresponding exponents. Okay, see here. So for multiplying two numbers also we are using the prime numbers concept here. So look here, multiplication of two numbers is equivalent to adding the corresponding exponents. So here consider given a equal to pi. Okay, p belongs to p. You know that what is small p, what is capital P. Small p is nothing but whatever the prime numbers you are taking for the number a. Okay, so to get a, okay, p is capital P is a set of all the prime numbers. Okay, here a equal to pi, p belongs to p, p of ap. Like that, b equal to pi, p belongs to p, p power bp. Okay, b suffix p. Okay, so here, okay, so how to multiply two numbers using the prime numbers here. So we need to multiply AB here. Okay, so consider k equal to AB. Okay, multiplication of two numbers, that is AB. Two numbers are here, AB. Okay, those AB are equivalent to, so here according to this one title, multiplication of two numbers is equivalent to adding the corresponding exponents. Okay, so here multiplying two numbers AB, that must be equal to adding the corresponding exponents. Here what are the corresponding exponents? For a, the exponent is a power p, sorry, ap. Okay, b, bp. Okay, so for adding ap plus bp, that must be equal to the multiplication of AB. So AB equal to AP plus BP. Okay, we should prove that. Okay, so here, so consider A and also B. Okay, so here we know that the integer k can be expressed as the product of powers of primes. See here, like that how we are taking the A, B, like that we are taking k also. Okay, so next, kp equal to, that means what is kab. Okay, so the title itself having that multiplication of two numbers is equivalent to adding the corresponding exponents, that is the two numbers are ab. Okay, so a into b equal to, okay, so a into b equal to a power ap plus bp. Okay, that is the meaning of this one. Okay, we should prove that ab equal to ap plus bp. Okay, here we are considering ab as k. Okay, so then we need to prove that kp equal to ap plus bp. Okay, for all p belongs to p. What is the small p? Small p is taken prime numbers, capital P is set of prime numbers. Okay, so next one is example for this one. So here k equal to pi, p belongs to p, p power kp. Okay, we should prove that kp equal to ap plus bp. Okay, so see here k, so here I am taking k as 12 into 18. So what is the k? K equal to ab, right? K equal to ab. We consider that k equal to ab. So here a value is 12. Here I have taken a value is 12, b value is 18. Okay, so now how to write this 12 in the in prime factors? Okay, 2 power 2 into 3. Okay, 4 into 3 is 12. How to write a 4? 2 power 2. Okay, 2 power 2 into 3 power 1 into how to write 18? 2 nines are 18. 2 into 3 power 2. Okay, so now you consider. Okay, now the result is 2 power 2 16. So here consider this first one, 2 power 2 into 3 12 value. Okay, so here multiplication of two numbers is equivalent to adding the corresponding exponents. Here it 12 is 12 is A, 18 is B, right? So the exponents of A are 2, 1. Yes, the exponents of A, that means this 2 and 1, this is the value of A, right? So we are writing this 12 in the prime factors. So the exponents of A are 2, here 1, 2, 1, 2 plus 1 is 3. Okay, next the exponents of, so the exponents of B, what is B? B is 18. We have written this B in the form of factors, so prime factors. So 2 into 3 power 2. 2 power 1 into 3 power 2. 1 plus 2, that is 3. So now K1 K2 equal to K3. Okay, so what we need to prove that is, so here 216, that is k equal to AB. We need to prove that k equal to AB. So here k 216 equal to, so 2 cube, so 2 power k2 and 3 power k3. Okay, so 2 power 3 into 3 power 3 equal to 8 into 27. What is 8? 2 power 3 value is 8, 3 power 3 value is 27. Okay, 8 into 27, 216. Okay, now k value is equal to this one. Okay, so next one more application of this prime. A divides B in terms of the prime factors of AB. Okay, so how A divides B, let's see in terms of prime factors. Okay, so the previous one is multiplication of two numbers, here the division of two numbers. Okay, so consider any integer of the form p power n. Any integer of the form p power n can be divided only by an integer that is of a lesser or equal power of the same prime number. See here, any integer of the form p power n, you consider any value, any integer in the form of p power n that can be divided only by an integer that is of a. Okay, so that is of a lesser or equal power of the same prime number. Okay, so you consider example here, a equal a value, b value. Okay, so here we are taking a pi of p power ap, b equal to pi of p power bp. Okay, so you consider a divided by b. If a divided by b, then ap less than or equal to bp for all p. Okay, so here if a divided by b, then ap less than or equal to bp for all p. Okay, so any integer of the form p power n, you consider p power n. So that is, so here I am considering the a, b as p power ap, p power bp, like that. Okay, you consider any integer of the form p power n that can only be divided by the integer of lesser or equal power of the same prime number. So see here, ap, okay, less than or equal to bp, that is the meaning here. You consider any value here, that is the power must be, okay, so that is less than or equal to bp. Okay, second one. Okay, so see here, a equal to 12, b equal to 36. Okay, consider two integers 12 and 36. Okay, A divided by B, that means 12 divided by 36. Let's see how to do when we are considering the prime factors for dividing the two numbers. Okay, for dividing two numbers. So here 12 divided by 36, so 12 equal to 2 power. So how to write this in the form of prime factors? 2 power 2 into 3. Okay, 36, 2 power 2 into 3 power 2. Okay, so hope you understand the up to here. So 2 power 2 into 3 power 2 is, so here 2, 3 are the prime numbers. How to take this 36? 2 power 2 into 3 power 2, 4 into 9. Okay, so next A2, B2. Why we are taking A2, B2 like that? Why don't we take 1, 2 like that? So here A power AP. So whatever the P here, P power AP, whatever the P you are taking, that must be the suffix of A. Okay, so here, so the prime number for 12, the prime number taken, the prime numbers are 2, 3. Okay, so 2, 3. Okay, that's why here I consider A2 and A3 only. And for the second one, B also, we consider the prime numbers 2, 3, so that I consider B2, B3 only. Okay, now see here, now A2 equal to B2. What is the A2? 2 power 2, A2, 2 power 2, B2. Okay, so these two are the, here 2, these two are the, okay, powers. Okay, A2, B2. Okay, now A2 equal to B2. Next A3. So what is the A3? 1. B here exponent power is 3 power is 1. Okay, here second one 3 power is 2. Okay, A3 equal to 1, B3 equal to 2. A3 less than 1 less than 2, right? So here A3 less than A3 less than B3. So how we can say that here for A2 equal to B2, A3 less than B3. We simply write that AP less than or equal to BP. Okay, so when you are dividing that, that must be less than or equal to the same prime number. Any integer of the form p power n can be divided only by an integer. Okay, that is of a, okay, so less than or equal power of the same prime number. Okay, that means less than or equal, here the same prime numbers 2, 3, here also 2, 3. Okay, so in this case only, okay, the prime numbers you taken are the same, must be same. So we need to consider the powers of that prime numbers. Okay, and we compare those two prime number powers. Okay, so here 2, 3 for 12, 2, 3 for 36, so the prime numbers we have taken. Okay, so we are comparing the A2, B2 and B3, A3, B3. So now those are less than or equal to B3. Is it clear? Okay, hope you understand about the prime numbers. And one more thing is, up to here we have seen fundamental theorem of arithmetic. Okay, multiplication of two numbers, A divides B. Okay, one more is here GCD. Okay, we can find the GCD of two numbers or two or more numbers using the prime numbers concept. Okay, so finding the greatest common divisor, GCD, greatest common divisor. Okay, so greatest common divisor, GCD. So actually how we how to find out GCD of two numbers or three numbers? Okay, so the, okay, how to find out? Let's see the GCD. See here, consider GCD of 15, 28. So 15, 28. Okay, see 28, 15. So here 15 once. So 15 to see, consider 15 to 30. So it is exceeding 28. So that we are considering 15 only. So the remainder is 30 now. So up to, okay, so up to the remainder 0, we need to perform the division. Okay, that is nothing but the long division we need to perform here. Okay, so to find the greatest common divisor, that is the GCD, there are ways here. So finding the long division, okay, performing long division, we are getting the GCD, we are getting the GCD. And another one is finding the prime factors. So here GCD, actually normal procedure is this one, performing long division. So here 15, 15 ones are 15, so the remainder is 13, it is not 0, okay, up to we are getting 0, the remainder is 0, we need to perform the division. So next, so we consider this one 15, next the division is 13, so now 113, okay, again we have the remainder 2, again take the dividend 13, okay, this 13, okay, so now perform the division, okay, so 6 2s are 12, next we got 1, next again it consider 12 here, okay, so 6 2s are 12, okay, so next we got the remainder 1, again we consider a dividend 12, okay, 12 ones are 12, okay, here the remainder is 0, when we got the remainder 0, so the divisor is 1, so we need to consider this as the GCD, okay, common division, sorry, greatest common divisor. So this is the greatest common divisor 1, okay, so like that we need to perform, we can calculate the GCD using the prime factors, okay. See here, this one is the using a long division, okay, performing long division we are calculating GCD, okay. So this one is finding the greatest common divisor using the prime factors. So let's see what is the GCD. The greatest common divisor GCD of two numbers, that is of two integers A and B. Consider A and B. Okay, so if you want to find out the GCD of AB, so what is A and B are the integers. Okay, to find out the greatest of A and B, okay, the greatest common divisor of integers A and B is an integer C, okay, so that divides both A and B. The meaning is here the greatest common divisor of integers A, B, that means GCD of A comma B equal to C, okay. So greatest common divisor of integers A and B is an integer C, that means C equal to GCD of A comma B, okay. That means C that divides both A and B without remainder, in the sense the remainder value is 0, okay, and that any divisor of A and B is A and B is a divisor of C, okay. So next, see here, by using this prime factor, so it is very easy to determine the GCD, okay. See the example of GCD of two positive integers if each integer has the product of primes, okay. So see here, example prime factor, here I have taken GCD of three numbers, okay. So if you don't want to take a three numbers, so you can consider only two numbers, okay. So here GCD of 24, 30, 36, prime factor of 24. First we need to find out the prime factor of 24. Prime factors, how to write the prime factors? You need those are the multiples of primes only, 2, 3, 5, okay. So here 24, how to calculate 24? 4 3s are 12, so 4, okay. So here 2 cube 8, 8 into, sorry, here we need to find out 24 factors of prime factor of 24. So 8 3s are 24. So here 8, how to calculate 8? 2 cube is 8, right? So we can write like that, 2 power 3 into 3. Next 30, 2 into 3 into 5, 2 into 3, 6 into 5, 30, okay. So 2, 3, 5 are the prime numbers. Next consider 36, 2 power 2 into 3 power 2. You should take that base value as the prime number. You should multiply the prime numbers only. Okay, so next the multiplication of prime numbers only. So here observe for the prime factors of three numbers 24, 30, 36. The common is here 2, 3. The common prime factors are 2, 3. 2 power 3 into 3. Second one 2 into 3 into 5. Next 2 power 2 into 3 power 2. Okay, see here for 3 okay, 3 numbers, 3 integers, the prime factors are the common 2 into 3, 2 into 3, 2 into 3. These are the common factors. So we can say that 2 into 3 are the common factors. Now how to calculate GCD of so now we can say that GCD of 24, 30, 36 is we consider the common factor among those values. So 2 into 3, so 6 is the GCD of 24, 30, 36. That's about prime numbers. Hope you understood. Okay, thank you.